Hello everybody, have a nice day today. So today we are going to start another important article of application of derivative that is written on the board, increasing and decreasing. The word increasing and decreasing you might have used in different fields of the mathematics in the previous classes. Dear students, if you see the graph of any type of function, sometimes you are finding the graph is going on increasing, the graph is going on decreasing. When in the previous class, let I remind you, when you are drawing the graph of the sin x, y is equal to sin x, the sin x graph you will see 0 to pi by 2. Just you visualize the graph yourself. Y is equal to sin x graph 0 to pi by 2. The interval 0 to pi by 2, the graph is increasing. Then pi by 2 to 3 pi by 2, the graph is decreasing. So, the very good thing of the calculus is that without drawing the graph of any function, the calculus is one of the mathematics we can tell you where or in which interval the graph is increasing and the graph is decreasing. And particularly the derivative application will help you without drawing the graph of the actual function. We can able to tell under which interval the graph is increasing and the graph is decreasing. So, to clarify these concepts, increasing and decreasing, I am taking two examples. Let us observe the examples very carefully. I am taking two linear equations, y is equal to x plus 2, one function. Another function I am taking, y is equal to minus x plus 2. Let us draw the graph of the two functions. So, obviously it is a straight line, it is a straight line. Y is equal to mx plus c. Suppose I am going to draw the graph of this function. So, let it is your x axis and it is the y axis. And the slope of the function m, here m is equal to 1. M is equal to 1 means tan theta is equal to 1. So, tan theta is equal to 1 means theta is equal to 45 degree. So, theta is 45 degree here and the y-intercept is 2 units. So, first you draw the y-intercept 2 units, y-intercept 2 units and the graph making angle 45 degree. So, let this angle is 45 degree. So, this is the graph of y is equal to x plus 2. Y-intercept 2, here 0, 2 is the point through which the graph is moving. So, let us draw this graph. In this graph, the slope is minus 1, m is equal to minus 1. So, tan theta is equal to minus 1. So, theta is equal to 135 degree. And again the y-intercept is 2. So, draw the graph. Y-intercept is 2. So, if the y-intercept is 2 plus 2 and the slope angle is 135. So, it is plus 2 and 135 means this angle is 135 degree. So, my question here, this is the graph of y is equal to x plus 2 and this is the graph of y is equal to minus x plus 2. Clear? I think it is clear. So, without taking the coordinate points that you have habituated in the class 10, I am drawing the graph of the two linear equations using the concept of the slope and a y-intercept. So, let us analyze this graph. So, in this graph you see, suppose I am moving from left to right. On the x axis I am moving from left to right. If the x axis is moving from left to right, the value of x is increasing. Say I am taking a point here, then the corresponding value of y is here. I am taking another point of x here, corresponding value is coming here. I am taking another point here, corresponding value of the y is here. So, it is clearly indicates that x increases, the value of x increases, simultaneously the value of y is also increases. So, dear students, once again you see, throughout the domain of this graph, when the value of x increases, so corresponding value of y increases. So, this is the example of an increasing function. So, it is an example of increasing function and increasing throughout the domain. So, this is an increasing function throughout the domain. Come to here. So, I am moving from left to right of the x axis. Suppose x is I am taking here. This is the corresponding height or the corresponding y value. I am going here, the corresponding y value, the value of y is decreasing. So, when x increases, y decreases. If the value of x increases, then the value of y decreases. So, it is called a decreasing function. It is a decreasing function and it is decreasing throughout the domain. So, once again you see, I have taken two linear equations, that is y is equal to x plus 2, another is y is equal to minus x plus 2, and the corresponding graph is drawn in front of you. And in this graph we analyze, when the value of x increase, the height also increase, means height means the value of y. X increases, y increases correspondingly, simultaneously, then it is an increasing function. It is an increasing function. So, y is equal to x plus 2 or f of x is equal to x plus 2 is an increasing function. But here just opposite we are finding. What is that? Now, when x is increases, the value of y decreases. So, the function f of x is equal to minus x plus 2 is an decreasing function. So, this is the bright examples. So, what is increasing, what is decreasing. So, write down 2 points. Point 1, the function f of x is said to be increasing in an interval if the value of x increases, simultaneously the value of y also increases. So, in case of decreasing function, similarly you write the definition by yourself. If the value of x is increases, but the value of y decreases correspondingly, then that is called a decreasing function. So, that example what I have cited here, this is the example of a function increasing throughout the domain and decreasing throughout the domain. I am taking a very familiar function that you know in the standard 11, y is equal to sin x, because it is the first graph of your trigonometry function. I am drawing the graph of y is equal to sin x. You draw with me. This is the x axis and this is the y axis. This is the origin. I am taking it is pi by 2 it is pi, it is 3 pi by 2, then you say pi, let it be 5 pi by 2, and it will be continue like this way. The maximum value is coming 1 and the minimum value is coming minus 1. I can write here minus pi by 2 and minus pi also. So, the maximum value is 1, so we will go up to 1. So, the maximum value at pi by 2 is 1, the minimum value at 3 pi by 2 is 1, and the graph is looking again at 5 pi by 2, the value is maximum 1, and it will come to the back side, in the left of this origin, again the same thing will get the value of x and y maximum 1, the value of y is maximum 1 and minimum minus 1. Dear students, look at this. So, see, from 0 to pi by 2, you analyze the graph. 0 to pi by 2 the interval, 0 to pi by 2, I am including both say. 0 to pi by 2, the value of x increases means the value of y also increases. That means the function is increasing from 0 to pi by 2. Similarly, pi by 2 to 3 pi by 2, see the interval. When the x is increases, the value of y decreases. So, the function is decreasing from pi by 2 to 3 pi by 2. So, we can observe what is our observation? What is our observations from the graph? Observations from the graph 0 to pi by 2. I can take the closed interval or I can take the open interval, no issue for that. I can consider 0 to pi by 2, y is equal to sin x increasing, that is by our observation without applying any mathematics. Similarly, pi by 2 to 3 pi by 2, y it is decreasing. So, from the observations of the graph, if the graph is available, we observe that the function y is equal to sin x is increasing from 0 to pi by 2. As per the rule, x increases, y increases. Pi by 2, 3 pi by 2, the graph is decreasing, x increases, but y decreases. So, my dear students, we got 0 to pi by 2, the function is increases. Let us come to the mathematics. What the mathematics is used here? And here you see just at pi by 2, if you draw the tangent will be parallel to x-axis. Means dy by dx will be equal to 0. Similarly, at 3 pi by 2, the tangent is parallel to x-axis. So, 0 to pi by 2, if you draw the tangent on the graph, this is the tangent, at any point you draw the tangent. At any point you will draw the tangent, you will get the tangent or the slope must be positive. The slope is positive, means see, because suppose I am drawing one tangent, this angle is an acute angle, I am drawing one tangent, this angle is acute angle. So, 0 to pi by 2, when the function is increasing, the slope is positive, and exactly at pi by 2, the slope is 0. And again see, pi by 2 to 3 pi by 2, suppose I am drawing one tangent, the tangent you see, and this angle is obtuse. Suppose I am drawing one tangent here, so this angle is obtuse. So, this angle is obtuse, this angle is obtuse, means tan theta less than 0, means the derivative is less than 0. So, here we can take the conclusion. What is the conclusion? If the function is increasing in a particular interval, so no doubt the slope of the tangent at any point in between it is greater than 0. That is dy by dx greater than 0, or that is f dash x or f dash x1, where x1 belongs to any point in between the interval. Similarly, if the function is decreasing within a certain interval, then the slope is coming less than 0. If the slope is coming less than 0 means the dy by dx less than 0 or f dash x less than 0. So, it is very clear. So, we are able to apply the derivative here in the certain interval. If the derivative is greater than 0, so that interval the function is increasing. If the derivative less than 0, then in this interval the function is decreasing. So, these two examples I have given to you. Okay. So, let us see what we have observed in form of the definition I am writing. You just write down. Ready? So, write down for the function y is equal to f of x, if f dash x1 greater than 0, where x1 belongs to in the interval a comma b. I have taken the open interval, then f of x is increasing in the interval a comma b. So, what we observed from the y is equal to sin x graph, that I am writing for the function y is equal to f of x, if f dash x1 greater than 0, what is x1? Now, x1 is any point within the interval a comma b, and I have taken a comma b is an open interval. So, x1 cannot be a, x1 cannot be b. Then the function f of x is increasing in the interval a comma b. Similarly, I can write the definition for the decreasing. So, in case of decreasing, then f dash x1, just I am rewriting for the function y is equal to f of x, if f dash x1 less than 0, for x1 belongs to a comma b. Once again I am telling for the decreasing, for the function y is equal to f of x, if f dash x1 less than 0, x1 belongs to a comma b, then the function is called decreasing. Then the function is called decreasing in the interval a comma b. So, these are the definition, but we will prove it by the observation. We have seen if the derivative is greater than 0, the function is increasing. If the derivative is less than 0, the function is decreasing, but mathematical will prove how it is, whether it is true or not. So, let us see the proof that the function is increasing when the derivative is coming greater than 0 and decreasing if the derivative is coming less than 0. So, let us come to the proof. Write down proof. Again, the function y is equal to f of x, let the graph of the function, and I am showing a increasing function, say this is the function, and I am choosing a interval, say a, and it is b. That means we are going to show within the interval for the function y is equal to f of x, and I am choosing the interval a comma b. Suppose I am taking a point x1 here, and this is the corresponding f of x1. I am choosing x2 here, this is the corresponding f of x2. So, look at this graph. So, what I have taken? So here I have taken x1 belongs to a comma b, and simultaneously x2 also belongs to a comma b. So my dear students, you see x1 and this is corresponding f of x1, x2 corresponding f of x2. So now x2 greater than x1 and f of x2 greater than f of x1. So what I am getting? I am getting x2 minus x1 greater than 0, and simultaneously f of x2 minus f of x1 greater than 0, because f of x2 is looking bigger height than the f of x1. So I can write f of x2 minus f of x1 divided by x2 minus x1 must be greater than 0. I will apply the concept of the limits. Let the 2 points what we have chosen in between a and b interval, let they are very close to each other. Close to each other means let x1 tends to x2 or x2 tends to x1. If x1 and x2 are very close to each other, their difference will be very, very small. Let this difference is h. Let x2 minus x1 is h, and h is very, very close to 0. So if x2 minus x1 is equal to h is very, very close to 0, I can write x2 is equal to x1 plus h. Correct? Correct. I have chosen x2 minus x1 is equal to h, very, very close to each other, as close to 0 as x1 is close to x1. x1 is close to x2. So I can write here limit h tends to 0 f of x2. In place of x2, I can put f of x1 plus h minus f of x1 by h, and which is I am just writing this one. So once again you see minus f of x1 which is greater than 0. And what is this? What is this? This is the first principle of the derivative at x is equal to x1. So that is nothing f dash x greater than 0. So my dear students, we have chosen a function and we have chosen one interval. From the observation, it was found that the function was increasing, and practically we have seen by applying the concept of the limits, concept of the derivatives, and finally we got the derivative at f dash x1 greater than 0, means within this interval the derivative of any point is greater than 0 in case of increasing function. Similarly, we go for a decreasing function. So let us choose one decreasing function, the figure of a decreasing function. Let us draw the figure of a decreasing function. Figure of a decreasing function. So this is a decreasing function. So I am choosing, suppose this point is A and suppose this point is B, and I am choosing x1 here and x2 here. So the corresponding value of x1, the corresponding y value f of x1, and corresponding y value f of x2. So it is very clear the function is decreasing in the interval a comma b. So similarly you proceed you similarly. So here x2 proof. Here x2 minus x1 definitely greater than 0. But f of x2 minus f of x1, smaller minus bigger, but f of x2 minus f of x1 less than 0. If we take the quotient f of x2 minus f of x1 divided by x2 minus x1, it is negative by positive. So, negative by positive is also negative. So, what you assumed here? Now, here assumed x2 minus x1, let be h tends to 0. So, what we are getting finally? Finally, we are getting f dash x1 less than 0. So, from the two proof, it is very clear that the function is increasing in the interval where the derivative must be greater than 0 at any point within the interval. If the derivative is less than 0 at any point within this interval, the function is decreasing. Okay, let us go for another concept, that is increasing function and strictly increasing. Increasing and strictly increasing, decreasing and strictly decreasing. So, we will write, I am drawing some figure, you draw with me. I am drawing some figure, you draw with me. The figure is like this. I am taking this one like this. This is a, suppose, graph 1. And I am taking another, this is the graph 2. Similarly, I am drawing another graph here, say like this, like this, like this. This is the graph 3, say, third graph. Similarly, I am taking, this is the graph 4, the graph 4. Okay. In the graph 1, you see, it is an increasing function. It is increasing function means the derivative f dash x greater or equal to 0. It is increasing function. It is increasing function. It is increasing function. Note down here. It is increasing function. So, derivative greater or equal to 0. And it is only increasing. Sorry, it is strictly increasing. Strictly increasing. It is strictly increasing. So, here f dash x only greater than 0, not equal to 0. Let us see, I am explaining why. Here you see f dash x greater or equal to 0. From here to here you will see, so definitely it is an increasing function. But here you see the graph is parallel to x-axis where f dash x is equal to 0. Again it is increasing. So, if I take the interval from here to here, I can say the function is increasing function where f dash x greater or equal to 0. But here you see f dash x greater than 0 means there is no chance that f dash x is equal to 0. That means at any point on the graph you cannot draw the tangent which will be parallel to x-axis. You cannot draw one tangent which will be parallel to x-axis. So, it is strictly increasing where greater than 0, already simple, it is the increasing function greater or equal to 0. Similarly, obviously, it is a decreasing function. It is decreasing. Decreasing means f dash x less or equal to 0. And it is strictly decreasing. Strictly decreasing. And strictly decreasing means f dash x less than 0. So, these are the 4 figures. Figure 1 increasing function, figure 2 strictly increasing, figure 3 decreasing, figure 4 strictly decreasing. Here also I cannot draw any function at any point which will be parallel to x-axis, which will be parallel to x-axis. Where the tangent is parallel to x-axis, so the derivative is 0, and these are called the turning points or turning point. So, these are the concept of strictly increasing and increasing, strictly decreasing and a decreasing functions. Okay, students. So, what we have discussed, now we will summarize it and we will tell you one algorithm or the steps how to find the intervals for increasing and decreasing of a function. Please note down the algorithm or the steps to be followed to find out the intervals to detect where the function is increasing or decreasing or strictly increasing or strictly decreasing. Write down. Write down the point 1. Algorithm point 1. Find f dash x or dy by dx. That is point 1. Put f dash x is equal to 0 and hence find x is equal to x1, x2, x3 dot xn. How many values are possible? Which are the turning points or critical points? So, during turning, at the turning point or critical point, the function is neither increasing nor decreasing. The third point, write down. Put all those values of x, that is x1, x2, xn, on a number line or domain of the function. So, once again the third point, put the values of the x in the previous case, that is f dash x is equal to 0, on the number line or the domain of the function. The fourth point, select a point at any interval or select a point in between any interval and put on f dash x. You choose any point, say x1, within a interval and put the point on f dash x, means on the derivative. If you are finding f dash x1 less than 0, then declare the function is decreasing within this interval. And if you find f dash x1 greater than 0, then declare the function is increasing within this interval. So, once again, if the f dash x1 less than 0, the function is decreasing within this interval. If f dash x1 greater than 0, the function is increasing within this interval. So, these are the algorithm. So, when you will start any problem, then we will follow this method and it will be easier. So, let us discuss some problem based on increasing, decreasing, and here we will categorize the two type of questions here. So, type 1 and type 2. Type 1, the type 1 is like this. Type 1, the type 1 proof that the function is increasing or decreasing in a given interval. Means the given interval will be given, then we have to show that the function is increasing or decreasing. Type 2, find the intervals where the function is increasing or decreasing. So, two types of questions we will discuss in this article. First, here one interval will be given and we will check whether the function is increasing or decreasing. And here one interval will be given, here interval will not be given, you have to find out the interval and you will declare in which interval what is the behavior of the function. So, let us discuss one simple question. Already you know. The simple question already you know. The first question, prove that f of x is equal to sin x is increasing in the interval 0 to pi by 2. Suppose I am taking the closed interval. It is increasing in 0 to pi by 2. So, very simple, because already I told whatever the functions will be given, first you find the derivative f dash x. So, f dash x is equal to cos x. It is one mark question only. It is only one mark question. Check or prove that the function f of x is equal to sin x is an increasing function 0 to pi by 2. In the beginning of the class, I have drawn the figure of y is equal to sin x. And from this graph, it is very observed that the function is increasing in between 0 to pi by 2. So, f dash x is equal to cos x, and cos x in 0 to pi by 2 means in the first quadrant. So, cos in first quadrant is positive. So, I can write f dash x greater than 0 when x belongs to 0 to pi by 2, 0 to pi by 2. So, f of x is increasing in the interval 0 to pi by 2. So, this is a one mark question. So, thank you very much students for your patience hearing. So, today only we have discussed about what is increasing, what is decreasing function, and we have seen or observed from the graph, and mathematically we have proved that f dash x greater than 0 in a certain interval, then the function is increasing. If the f dash x, the derivative less than 0, it is decreasing. Both mathematically and graphically we have seen and we have observed, yes, this is the right concept for finding the increasing and decreasing of a function. And finally, I have discussed the algorithm or the steps how to find the intervals where the function is increasing, decreasing, or how to prove the function is increasing or decreasing if the interval is specified there in the question. So, thank you once again. Thank you for patience hearing, and I have given some home assignments, and I hope you will finish all this home assignment, and the next class, if anybody having any doubts, we can discuss. Thank you. Have a nice day.